briefly. It was really tough deciding which slides and how many slides to put in here because everyone likes to see the demonstrations. So we're going to do our best here in an hour to kind of talk about data science is if not, I mean, we can do it, but there's still so much left to be uncovered, right? And at the end of this demonstration, we're going to show you and talk to you about a follow-up resource that you can take advantage of if this answers certain questions, if this entices you, if this excites you, so this is something you want to go on and learn more into and maybe incorporate. We'll have an opportunity for you here that we will bring up at the end of the call in regards to some of our on-demand training, which will take what we've learned here and extend it far beyond. So what's Azure Machine Learning? What's that all about? In there's obviously going to be a little bit of discussion of data science just as a whole, and what's the ML development process like in regards to specifically how do we do it within ML Studio, so Machine Learning Studio. That's going to be the environment the developer interface will be using. And then we're going to go through the process and create a predictive model. And we're going to talk about this term, but we're going to create a forecasting model. There's a couple different types of models that you can create, and we'll see those terms, but we're going to be doing a forecasting, which really that's the kind of the one you most think about. We're trying to predict a value, right? And we'll run through the parameters of the demonstration just before. Just in case, my contact information, which is available here as part of this presentation, it'll be made available after this. This is recorded and we do put it up on our website post, so you can kind of take this piece by piece and consume it at your own pace after today, which might be the case, right? I'm going to be using a data set that isn't necessarily part of the shared data sets, something that actually is part of our on-demand training, but there is a similar data set. It will just require more of the cleansing process, which is fun. So we're going to see that process here, and then you could go and use that shared data set and do the same example, but just using a different data set, because I'll show you that. It has acceleration in there too. So you got to peek behind the curtain on what we're going to predict. Really quick, this is what we're going to be looking about in regards to the ML basic workflow, where we're bringing in information. It does a really good job with cloud services. That's primarily what we're seeing here on the left-hand side, like bringing those in as sources. But just know that for the paid version, we'll speak about that in a second. You do have this option. It's in what they call preview mode right now, or beta, but on-premise SQL Server is also an option. But we can bring that stuff into ML Studio, create our experiments, we design it. Once we're satisfied with the end results, we can deploy it and then leverage that through an API. So some of this conversation at that point might be a little bit beyond the scope of what you're looking to do, but of course you create and develop an experiment that's going to help you in making predictions. It's the purpose. And then of course you need to put that in the hands of those users who need that information, and they'll access that via API, whether it's an intranet, whether it's an app or some sort, but usually there's going to be like an app or an API team there that can assist with that. And then of course the last piece is the actual consumption of it, going through the API saying, oh, you know what, this is the information that I have, let me give you that. What is, let's get a predicted value, let's feed that into our model and get back a response. So that's the whole life cycle of it. So when it comes to Azure Machine Learning, the approach that I'm going to be taking here, and I'm going to show you real quick, it's the first thing we're going to do, is where do you go? What's ML Studio all about? How do I get signed up? And the good thing is, yes, there are costs. What we're talking about here in this slide is more of the production element, like fully invested, what would that look like? And we'll see that momentarily. But there is cost associations. Basically, the cost is going to be around workspace and storage. So a combination of the two. And then lastly, 3, the consumption via the API. That's where all the costs really come into play, and there's varying tiers of this, which we can look and examine here momentarily. But I'm going to show you, you can sign up for free. Basically, you just need to have a Microsoft account. This will create a free workspace. It goes up to 10 gigabytes of spaces in there, which is plenty for just tinkering and toying. And they have tons of readily available sample data sets and freely available downloadable sample experiments. So you can find something that maybe fits your needs, bring that down, look at it, use it as a basis of comparison, or just modify, take it and then twist it to your own. So lots of good stuff. We're gonna be working here. So you just, you can't do this all because there is a free component of it, but of course, if you're here, you're probably interested in, this might be a solution for my organization. What do those costs look like? So this is where we're going to be heading momentarily, a little bit of screenshot. There's a lot of momentum around Azure and Azure services. ML being one of those services, right? So there's a good chance that some of these things will be changing through the Azure portal. They have some preview elements relating to machine learning too, basically more that developer side, that deployment side, the API side. They've been making some changes there. So there's a possibility that this could undergo some transformations in the future because it's growing right now extremely in popularity. But studio.azureml.net is right now what it is. We're going to go, we're going to visit, we're going to enjoy. There's so many links on there too that can further what we're talking about. Some very quick 5-minute videos on, this element of creating ML experiments, or what does this module do? I want to use this module that we didn't cover. What is it all about? I'll show that and point to you, but there's some fantastic resources right here. So that's where we're going to be going when we dive into creating the experiment. But before we get there, a couple just little terms, right? The idea of data science is just extracting knowledge from data. That's the nice, broad, clean, textbook Webster kind of style definition. But we're going to do that in a couple methods. Statistics basically is what machine learning is born from. The idea is collecting information, a smaller sample set that is supposed to represent the whole. That's the idea behind statistics, and the key and the quality control behind statistics is ensuring that the sample set is within an established set of parameters, right? You want to decide what do we feel would comprise like a sample set that it would be well defined as far as representing the whole. So when we come to things like statistics as a whole, it's really tough to completely validate that. Only because usually we're predicting the whole, as we mentioned, and to validate it, you have to go to the whole, and generally it's like taking, let's just say, like in the US, right? How many people prefer, here's a terrible one, Wendy's versus McDonald's, right? They're going to take a sample set, and depending on the parameters, where should we go to this? How many major cities per state? Who should we look at? Is there an even distribution between male and females? All of these parameters need to be established and defined as when we collect that sample, it falls within it, so we can feel comfortable that yes, this is what we feel is good, and it will be acceptable to represent the whole. Well, machine learning is born from that. We use and make the efforts. For us, we're going to dive in to do some things called predictive analytics. So there's predictive and descriptive analytics when you talk about creating an Azure ML experiment, and it's more about the approach, it's more about the design, because as it sounds, we're creating models or experiments that learn patterns of the data. That's where that all comes in. And we're going to see that that's going to happen in the modeling phase, where we feed it into some sort of algorithm. We take some data, and we're going to talk about when we create the experiment, this idea of testable data. So you have to give it data that has your answer, right? That's how it works. We give it and we see so it understands and figure out very evident, obvious patterns of the data, and some that are less obvious. That's when we start moving more to predictive. And there's various types of algorithms here. We're not going to cover all of them because there's quite a few, but there's some that are easy to understand, like a linear regression. This is something that has an established formula. You can look at the weights that have been assigned. So we have all of these columns. We're going to call those independent variables, independent columns. There are predictor columns. And then we have a column that represents our target variable or our label. That's where we're going to see that's what it's used as. We're trying to predict some value, and these are the columns that are going to help us do it. Now the goal is to pick the best columns that can help us with that. Because if we leave certain columns in there, patterns might be discovered that would actually give us false information. And that's where really the hard work and effort is done when we talk about establishing and creating experiments and data modeling. It's figuring out what makes up a good predictive model. And when we talk about the 6 different steps of creating experiments or a predictive model, the data modeling, basically the data preparation, that phase is really going to take the longest. All right, that's going to be a process where you're really moving forward, seeing, testing with what you have, making changes. That's why it's called data science. Think of yourself as a scientist. We're doing an experiment in the development process, and with this experiment, you're doing repetitive trials and experimentation and recording those results, and then finding the most effective, most efficient experimentation with the most effective, positive results. So that is very common. That's why that phase takes a while, because you might think, all right, these are my 9 columns. Let's clean it up in this way, this form and fashion. I'm not really certain about column 9. Let's leave it in for now. What's our score? How's the predictive power? Okay, let's remove column 9. Did that help out? Was it figuring out, did it collect some false patterns? Was it better or not? That's the whole idea. You gotta remember, this name science is in there, so we want to follow the traditional scientific process. That's the idea there. So I just saw that there was a question here, so I'm gonna expand this in case I see something of critical importance here. 1 second. And just in case, to acknowledge questions, I'm not going to take them immediately throughout the webinar, just because, yeah, that'll kind of break it up. But if you have questions, put them in there. If there's time at the end, I'll try to answer a couple. But they provide me some great options for either emailing you, depending on the specificness of the question, or just creating a blog. But to return to what I spoke about, predictive versus descriptive analytics, that's the idea. We need to learn patterns of our data so we can predict it. Now, just so you know, some key terms there is what we're trying to find out is we're trying to discover what's known as the signal. The signal is basically that perfect line that makes an understanding of the relationships of the data and what we want to predict. We want to get as close to that signal as possible with reducing what's known as noise. So as I was saying, those false patterns and information that might be, going in the wrong direction, they create what is known as noise. So our job as data scientists or, machine learning experiment developers, model developers, is to reduce the noise. So that's the goal. And we are going to create a model. And a model comprises of everything, the data, the modeling phase, what algorithms we're using, all those pieces. And we're going to see that inside of our Azure ML experiment that we create, we're going to be using modules throughout it. Those are basically the drag and drop items that we're going to see which exists within a toolbox that's at our disposal there. So I mentioned there's a couple different types of models we can do. Basically, this is what we're trying to predict. That's what this is meaning. What type of model are we making? We are going to do a forecasting model, or otherwise also known as a regression model. This is where we're trying to predict a straight up value. In our case, we're going to try to predict acceleration, but there's other examples I'll talk about that. There's some pre-canned ones for samples to predict the miles per gallon for a vehicle, utility usage, temperatures, based off of weather patterns. Another one will be classification, and I was going to say this actually for the regression, but that would be, is your flight going to be delayed or not? The idea is, it's when we say a binary outcome or category, we're just categorizing. It's going to fall in binary. We're saying either one of two options. Is it going to be delayed or is it not? Does this individual make more than 50K or under? We can predict, salaries, depending on, their prerequisites for their qualifications. One of two, or there's something called multivariate as well. So with classification, you can have it be between 1 or 2 items, or 1, 2, 3, 4, 5 different categories. What is the prediction of how well received this book is going to be based off of other books, right? Is it going to be okay, good, bad, and satisfied? Maybe those are the categories that we have established before for a rating system. That's going to be a multivariate. So we're going to have multiple options for classification. As well, we have anomaly detection. This is where you find those patterns, and anything that falls outside of that pattern kind of gets prompted and indicated as such. This is very commonly used in, as you can see right here, fraudulent transactions. So a lot of banking institutions kind of leverage this anomaly detection. Clustering is a little bit different out of the group. This is going to be something that's called an unsupervised learning. So not to go too deep into it, but everything else, classification, regression, anomaly detection, we call it supervised learning, and you got to think of it like we're talking about science, and we said learning, machine learning, so that's where that teacher element comes into play, that supervised learning, because we are going to be in control and say, okay, yes, I'm going to pass this data, which includes the answer, into this algorithm. Let's just say it's a linear regression. I can tweak how it's going to accept this. There's parameters for each of my algorithms I can manipulate, tune up or down. I can modify the data. I can see the results. Because we are feeding it information that already exists, the answers, we immediately get to see how well is it predicting this, and we can adjust that. We can modify it and say, well, I think it's picking up something odd from column 7. Let's tweak it. Let's get rid of that. Let's do something else. Let's modify one of its parameters, and then we run it again, and we see how now it understands the data, how it's figured out the patterns now. That's what we talk about supervised. While clustering, really we don't know information about the data. We're trying to just say, hey, you know what? I'm not certain what patterns exist here. Go ahead, just look at the pattern and tell me, and start to group or bin these items for me so we can find out what commonality, what types of correlations exist, what relationships exist between it. So clustering is just another type. And there's recommendation, which sometimes is known as called prescriptive. Instead of, we saw predictive, descriptive, there's also prescriptive modeling. But that's something we're not going to be covering today. The specific one that we're going to be doing, regression. That's what we're focusing on today. So the 6 steps I promised you, this is what we're going to be going through. First is getting the data. And really, the first 3/4 should be familiar with anyone who has worked in the BI world, all right? I say /4 because like part of the 4 process is a little different, but getting the data, cleaning the data, and transforming the data, that part there is very standard if you have any sort of BI background, because we're just, where do we want to get it from? Are we importing something from a CSV, text file, Azure SQL DB? As I mentioned, if you have it paid, you can go into the on-prem SQL server. How do we need to clean this up? Let's remove some columns. Let's normalize the data. Let's change the name of a column. Let's modify data types, things like that. All of that's available. And of course, transforming it, that's where actually more so when I mentioned the normalizing piece. Modeling is where we're going to go ahead and take that data, and then we're going to choose what type of algorithm. And what's fun is when you're experimenting, generally you're going to pit multiple models up against each other. So as you're designing, you say, well, as I was examining, doing some exploratory data analysis, EDA, it looks like the data is more linear, so I'm going to go this route. But you know what, just in case, let me do a more predictive style algorithm, something this is where you get things like deep learning or black box algorithms, items that are less understood. Basically, you know the information you're passing in, how that's being manipulated, how it's discovering patterns is less understood. So that's what we mean when we say predictive, where we know what comes in and we can see what comes out, but we're uncertain about that middle process, how it's leveraging this, what are the various weights it's applying to these independent variables. That's what we talk about when we say predictive. So maybe we pair it up. We say, you know, I'm gonna do one predictive, like a neural network's a very popular one, versus something that's more descriptive, where we can see what weights are being applied. We know the coefficients. We understand the formula. You know, we use a machine, obviously, so they can process all this data information, but it's still far more explainable, easier to understand. So you pit them against each other, and we see which does better, and that's going to be the model we end up going with. Now, 5 and 6, this process, even though I'm saying it's unfamiliar to the BI process, this is more specific to the machine learning part of things. It's actually very easy. Once you get past those steps 1 through 4, and like I said, kind of it's like half of 4 really, choosing what algorithm to use, scoring and evaluating it, and the deploying, these are actually the quickest and easiest parts of the process. It's steps 1 through 3 that are the most critical. That's where you're gonna have to go back anyways. That's where you do the maintenance, because once you deploy a model, it's kind of like how they talk about like a vehicle, how as soon as it gets driven off the lot, it loses value. Well, it's not that instantaneous in regards, but a model potentially will deteriorate over time. So you don't just create a model that scored well here and then just leave it be. This is a constant monitoring process. You revisit it because data does change. The patterns that it had learned might alter because of something, geopolitical events, some sort of social media outlet, some rampage that went on that might have, you know, tailored something away, some sort of boycott if you're in the retails. There's a lot of things that could change and alter, and then your predictive model is just gonna go way down. So maintaining this and then needing to go back into the area to look at the transformations that you've done, maybe we need to alter it. That's the phase 1 through 3. That's where the work is done. And that's really that's the big thing for data science. So for us, of course, we're gonna look at ML Studio. I'm gonna show you a rundown of a couple things. Well, what we're gonna be doing is we're gonna be predicting acceleration. We've got some independent values, some X items like the make. These are our predictor columns. We've got make, model, horsepower, weight, displacement, cylinders. There's a bunch. We'll see the various columns we have at our disposal. We're going to be doing supervised learning. We are going to be doing regression. That's what type of model we're creating, a regression model, a forecasting model. And within that, once again, remember when you're creating this, you have to have training data or testable data. We need information. So there is a cost when we talk about creating machine learning in the development time. You need basically data that's already passed, it's done, so you're not doing it. The whole purpose here is we want to see ROI, but the more testable data you get, you got to figure you're kind of losing some value there, but we need it. We need information. We need to know those answers so we can say, okay, yes, it's going along, it's figuring out, it's doing some good predictions, bam, let's throw it out there and put it against data it's never seen. And we watch, we monitor, we make sure that that is true. One thing I write down, because of what I just explained, when you create a model and you get these fantastic, and we're gonna see there's something called coefficient of determination. Basically, when we figure out what the predictive power is of this experiment, and then we deploy it, but in real time, we're not getting nearly the results that we expected. It's supposed to be 75%, but we're seeing 30%. That could be a case of the most common issue that occurs with machine learning, which is known as overfitting. So that's just a term I would kind of take down and note. It's a very easy problem to come with. Really, the way to there's a couple blogs and methods you can do to approach this using multiple sets of testable data. There's some approaches you can do within the modeling experience to try to maximize that, but the more you feed in, the less potential overfitting would happen. So we're going to look at that. We're going to use regression. We're going to throw in a couple algorithms just to take a look, and then I'm going to just show you how easy and quick it is to deploy it. All right, so with no further ado, let's head over and launch studio.azureml.net. Now, I'm not going to be going at any specific pace that would, it's not meant to be follow along here to a degree, right? That's why if I did, I would be opening up the volume chat. It's 100+ people here, that'd be too tricky. So I'm just going to go at a pace that you can see, experience, so just consume this. Remember, it's recorded. You can watch it back at your leisure. So when you go to studio.azureml.net, this is where you'll be landing. And if you don't already have an account, you can go up and hit straight up sign up here, which shows you, and this gives us a general rundown of the charges. The 8-hour trial is equivalent to the enterprise grade, but it's for a specific amount of time. The center one, that's that free one. I'm going to show you. I'm going to log in with my Gmail account, 10 GB storage. You can run R, you can run Python, you can create predictive web services. You can sample it. So it's just for that developer interface. And then the traditional one here is the standard workspace, $9.99. It doesn't give you all the breakdown of what's included, and I'll show that here momentarily once we get signed in. But just click through here, you'll just go through the process, and you'll have yourself an account, which you can log into. So for me, I'm gonna sign in, and you'll see, I'll return to this momentarily, but that's the area where you have like the forums, some helpful videos. So I have 2 accounts, but I'm going to use this one here for the Gmail so you can see that you can get it all for free. All right. These live demos, right? You hope all the services are up and running. I checked before and it was, so we should be good here. So when I launch and go in, it's immediately going to bring me into the actual studio portion of this. So I'm going to backtrack for a second to go back to where we were. For a second, I'm just going to go in the upper left, there's these little 3 bars. I'm going to go back to home just so I can show something here. So I'm logged in, we can see the information. If this was a paid account, you would see your various different workspaces here, but this is a free one. So I have my one workspace. This is just a container, a virtual environment, which houses my data sets, my experiments, my projects. There's some notebook items we're not going to cover, but you can have it there. And you can invite people into it. It's a cloud service. That's the whole idea, being able to share this. But as I mentioned, tons of recent announcements on here. There's some really awesome, sometimes blogs you can access, so it's really neat to check up on. Here's these really easy, very quick videos, if you want to reiterate as you're going through it. And a really important area, but I usually just Google search it, is here, the list of modules. We are in no way, shape, or form going to be able to cover all the modules. Those are all the drag and drop components that exist in the toolbox, which you haven't seen yet, but there is a ton. So it's important to know where your resources are, because there's definitely a chance you're going to want to use something that I'm not covering. We're just doing one type of experiment. And we've seen many, many different types, and it's definitely going to be specific to the data that you're working with. So lots and lots of good stuff here. Let me go back in so we can get to the studio. I'm going to go here and I'm going to go to Azure Machine Learning, and I'm going to go to Studio. Now the gallery here, we're going to see it momentarily. It's a different place. that's where I mentioned there's a ton of experiments that you can grab, you can access, and just import into your workspace. So you can have it as a reference. There's some that are meant for helpful reasons, like here's like 10 different data cleansing methods, some really cool stuff, honestly. And this is what we're seeing. This is actually an example. You can see it's a sample 3 for cross-validation. Let's see what the full name of this one was. I just grabbed one. So this is using the adult data set, which is freely available, but when you download an experiment from the gallery, it'll make sure you get the data set if it's not one that's already shared, and that's our experiment. We can see it right here on the right. It gives us a little preview, and these are what I'm talking about. All these are called modules. And this is the modeling part. These are the different, so 2-classed average perceptron, 2-class boosted decision tree, logistic regression. So this is classification, and it's doing a 2-class, a binary classification. Those are gonna be the modeling pieces, right? So this is a sample. How and where did I get that? Because this is definitely important. Well, glad you asked. Down at the very bottom, we've got new. And when we hit new, in a moment, we're gonna be hitting blank experiment, but look at all of these. If you hit experiment tutorial, it actually does kind of a guided walkthrough of, hey, drag this over here. That's what this does. It's a nice little tutorial. It goes all the way through deployment, so that's always fun. But you can search, and there is a ton in this option, and you can also, in the upper right, go to gallery, because there's even more. And when you become professionals, and you have awesome models, and you want to share with the world, you're going to see there's an option that you can deploy your ML experiment to the gallery. So you can put it out here if you wanted, but tons of options here, right? If you wanted to, let me see if this has it on here, I haven't looked. So if you're looking for churn, basically customer retention here, what's the churn rate? There's a bunch of examples here on churn. Step 2 of 4, so tagging the data, feature engineering, training, evaluate, it's going through all the different pieces. So really awesome place that you can just get these awesome experiments that you can mimic, you can use as a basic example. So really, really powerful stuff. Now also, we're not gonna need to do this. You won't be able to do this because you don't have this, but this is also where you can import data sets. This is gonna be your CSVs, your text files, whatever it might be. You can simply go here, hit from file, and you can access that, you can bring that in. So for us, and actually what I'll do is I'll exit it, as you can see, we are going to go ahead and create a brand new experiment. So I'm gonna go ahead and do that. The other things, I'll just briefly, projects, if you wanted to just kind of organize multiple experiments into one location, you can create a project and assign experiments to it. Web services, you can manually create a web service, or as you see, we will go through this nice automated process and the web service will be placed here. Notebooks are for any of those who use R or Python. You can create Jupyter notebooks. Basically, this is just a method of storing some code that can be executed. You can upload them. This is where, of course, if we wanted to, if we had text or CSVs, as you can see, I have a couple here that I've imported. We can go there. Now, the settings is a fun little place too. If you've done the free thing, you're like, you know what, it's time to move forward. You can always go right here under workspace type and hit learn more, and it brings you right to this area where it shows off the pricing elements here. So as you can see, we've got our free, and it tells us exactly what it gives us. I scrolled a little too far, 1 second. And then we got the standard. As I mentioned, this is where you can go ahead and you can use the on-prem SQL. You've got this options, but then the pricing, this is where it changes, right? You have different SKUs for the website, the deployment side, the consumption side. So different tiers. This is something you need to look into when you go into those options. But we can move very easily from free, and you don't lose anything that you've done in this workspace. It will remain, it'll stay. So a lot of stuff. This is also where you potentially could invite users. You just go in here and hit invite more users. And I'm not going to go into this, but the data gateway is if you're using an on-premise data source, like that SQL Server option. This is where you can set it up to make sure that that information, basically you refresh, you pull the information from an on-prem and send it to the cloud. If you're familiar with like Power BI, the very same data gateway that you mentioned. So let's go ahead and create our experiment. It starts to get a lay of the land here. So I'm just gonna hit new. I'm gonna go with blank experiment. And it creates us a nice little silhouette of what a experiment should look like. You know, bring in your source, do some transforms, go in the modeling side, evaluate and score it. So We can't save it yet, and we can't do anything until we actually bring something into this. We actually have to have some sort of transform in here. So we have to start from the source. Now there's a couple of options, right? We can do this. I'm not going to do it, but I want to show you. We can go import data. This is a pretty fun one. When you do this, you can see that you have a wizard you can do, which just kind of walks you through this process, but this is where you can access Azure Blob Storage. You can go to a web URL via HTTP. A very common one is the University of California, Irvine. UCI has a fantastic library of machine learning data sets. So if you want to take a note of that, UCI, great area to download data sets. A lot of the data sets here that are available from Azure is from there. Hive, Azure SQL DB, Azure Table, lots of fun stuff here that you can straight up import from the web. As well, for other sources, show this here. We have this datasets area. Now, initially, when you first launch this, you're not going to have anything in the My Datasets. I do because I've imported the datasets. We saw those. But here in the samples area, this is actually where I was mentioning. These are all just readily and freely available. If you, I believe if you download a sample data set, let me look actually. I'm pretty sure, no, actually it goes here. If you download one of those sample experiments and you save it to your workspace, it'll actually put the data set that correlates to it here in your My Datasets. I forgot about that one. But look at all this stuff right here at your disposal, just fun, ready to use. So you can definitely, right after this call, go right ahead, just bring stuff in. And what you're gonna do is exactly what we're gonna do. This is all unfamiliar data to us, right? I mean, I know it a little bit. I looked at it a smidge before this call, but I'm gonna go ahead and grab this auto acceleration. Just so you know, there's a very similar data set to this. Automobile price data raw does have acceleration. That one is more driven towards predicting miles per gallon, but you have acceleration. I think it's missing a couple values, so that's the trick. You'd need to get rid of those missing values, which we'll talk about. But it's there. It is an option. But for me, I'm gonna go ahead and grab auto acceleration. Just click, drag it in. That's what we're working with. For all those individuals that had said they created predictive models and it was more in R, yeah, you don't have to do the code. You're just working in this GUI, which is fun and what's nice. And you'll see as we go through this, when you hover over one of these modules, it gives you a quick description of exactly what it's doing. And I'll show you quick help. Remember I said that link that gets you to all the modules, kind of a help area? For every module, the quick help will have a link to go to that. Extremely important when you're first starting out. So for us, the first thing that needs to be done when doing any sort of type of experiment is you gotta do EDA, exploratory data analysis. We gotta have an understanding. We gotta start thinking about, looking at those predictor columns. We gotta look, one, this is what we're predicting. We know we want to predict acceleration. So when we click on a column, you get some really great things. You can see, of course, at the top, we have these nice options for histograms just readily visible. Then that histogram is brought into kind of focus here in the right-hand side. But we want to see, there's fun things, mean, median, min, max. These are helpful things just to get an idea. For me, though, since we're looking at acceleration, remember this is called the label field or the target column or the dependent variable, a couple different ways they call it here. Label is a very common one. That's the one that we're going to see most often here when we're developing. But missing values, there's none. That's the key thing here. And what's fun is you can do other things. This is where you need to start making assumptions. Remember, it's a scientific experiment. Make some hypotheses. Which of these columns will be helpful, right? Which one of these probably have the easiest, most obviously identifiable relationships? You could probably say something like weight, right? The heavier a car is, now I'm not certain, I'm just grabbing the column to the left. The heavier a car is, probably the slower the acceleration. And what we're looking for is lower values here for acceleration. So you can see there's the majority, this shows us the distribution. It's a pretty nice, even distribution, called like a Gaussian distribution, really nice and even there. But the lower the number is quicker. So we can probably say the heavier the car, the higher the acceleration. So it'll be worse acceleration. And we can check that, right? Acceleration is selected. We can compare it to weight. And when we do this, you get an interesting type of visualization here. what we're seeing, this is what I would call, you can kind of draw a line, but the line is really terrible. That's the idea. When we think about, we want to try to figure out which ones of these have linear relationships. And the idea is you want to be able to draw a line through the middle. You've usually seen that. That is that kind of the average line between them all where items fall to the left and the right. That's what mean absolute error is based off of here. But there's going to be a large spread away from the line here. So this is leaning more towards nonlinear. So that statement I made where weight increase would mean slower acceleration isn't necessarily true. And we have to think about the realms of probabilities here. But if we switch this to something like horsepower, this becomes far more linear. You can more easily imagine a line being drawn. Sorry, 1 second here. I wanted to make a line here. You can see kind of a line drawn right through there. You can imagine it, probably a little bit lower because there's a lot more distribution here in the bottom. But that's what we're doing. We're saying, okay, I really like horsepower. Horsepower is a great predictor column. Weight, it's got something there. Remember, visible, like obvious, and what's known as also hidden patterns. There still could be some correlation there, but maybe we don't apply as much. It's weird to use the same word to define a word, but a weight of coefficient, we're saying how much should weight affect the prediction. This one may be a little bit less. I like horsepower a ton. I have a feeling cylinders is probably going to be the case, but cylinders is more of what's called, if we look at this, when you see this, you're working with something that has a lot of, you're looking at a column that does not have a lot of distinct values. There's not a lot of cardinality. And if we look at cylinders, out of the 398 rows that we have here, as you can see in the upper left, there are 5 unique values. So this is definitely what we like to call a categorical value, a categorical, and I'm going to use this word. If you're used to saying columns, that's fine, but they're known as features. These are all features. So this would be what you would call a categorical feature. And usually you want to go ahead and change these data types. If we were to change this into categorical, we get these nice box plots, which makes this look a lot better. So let's remember this, right? We said, you know, more than likely there's a lot of correlation between horsepower and cylinders. I'm not a car expert. I'm just thinking if you have 8 cylinders, you probably have more horsepower. Now, even looking at this, you can pretty much kind of say that. There's a pretty broad range on the 8 cylinders, but the highest horsepowers definitely belong to the 8s. And 6 is less and 4 is less than that. Now, we do have some oddities here, right? We have a 5-cylinder and we have a 3-cylinder. There's only 4 points here and 3 for the other. These potentially one of 2 things here, right? These could simply be what are going to be outliers, these oddities that could cause false patterns to be learned here, or maybe it's part of the data set we received. I've only got 400 rows here, 398. Maybe just I didn't get many of the 5 and 3s. Now, you can probably imagine, what the heck, 5 and 3. This data set, as you can see from the model years of the vehicle, is a little bit older, but this is what we're doing. We're looking at this and we're trying to evaluate what's going on with it. So that draws attention to me. So let's start to clean some of these things up. The first thing I usually start with is going to be the removal of columns that we do not like. We had 2 columns here, definitely in particular, that I want to bring to our attention. Now, when you click on here, this little data set, if you right click, that's how you're able to visualize. I'm model and year, origin and model. I mean, look at the distribution here. If we were to compare this to acceleration, it's all over the place. Why would year have any impact on this? I didn't mean to close that out, pardon me. Why would year have any impact? So this is an example. This is out. There's nothing I can do to transform this to make this truly even viable. And origin as well. If we look at origin for acceleration, what we're talking about here, I mean, there's a little bit. Number 2, 1 represents United States, 2 represents Europe, while 3 represents effectively Japan, but Asia. I mean, there's just more sample set from America. Yeah, they make some lower ones. I don't really think that origin also is going to, if anything, it's going to be a mild weight, but it potentially could add, rather than getting us closer to the signal, because that's what we want, I think it's going to get me closer to the actual, to give me more noise. So, model year and origin, they're out of here for me, all right? So I'm getting rid of that guy. 1 second here. Trying to minimize this here. So I'm going to get rid of model year, and origin. So let's get rid of those guys here. So we're going to go ahead, and there is a lot that goes on in this toolbar. So I usually use the search term to bring this up. and this is select columns. So you kind of have to spell it right. Oh my goodness. Select columns. So we're doing select column and data set, and you just drag it on over. And if you've ever done SSIS, a little bit of familiarity here, you just kind of click and drag and connect. So now we've brought this data, it's going to go into select column data set, and we're left to configure this. And we have this right here, right-hand side. If we need more information, what the heck does this do? More help. But we want to go into column selector. We're going to go in here and say, I always like going with rules. So I say, I'm going to start with all of my columns, and then I'm going to exclude model year and origin. Just like that, done and done. And you can either continue to develop and design, but I recommend whenever you're making a manipulation like this, like removing columns or adding columns, run this, because it's going to store it basically in memory as part of this experiment. It's going to store it so that now every module that we add after the fact is working with what's current. So 7 columns instead of the effective 9. So you just do a quick little run. The upper right-hand corner here is going to show that it's executing, and we're going to get hopefully some nice green check marks. Then we can continue. So we got our green check mark. Now we can look at this, we can verify. You can go in, once again, right click and hit visualize, and we're going to see we still have 398 rows, 7 columns. We got rid of origin and model. The rest I do like. I think we're in great shape. Car name, this one's interesting. This is one I want to bring attention to, and we're going to tackle this next. 398 rows, 305 unique values. There's a lot here. When you have this grade, I mean, we're approaching complete cardinality here. You do not want, how are we supposed to find patterns of this? We're not going to be able to. We want a lower count here. And what we can see is it's a make. It is our make and model. Chevrolet Cheville, Buick Skylark. So you can see in the good example right here, Ford Torino, Ford Galaxy. Let's take advantage and clean this up and say, you know what? The make is, the model part is what's making this distinct. How many makers do we have here? Because that could be something, right? You know, if it's a Chevrolet, they lean to more performance vehicles or whatever it might be. That might make more sense, but we'll have to see. We'll have to see how many unique values are left after we clean this column up. The way we're going to do this is with a little bit of fun. For those of you who said you use R or Python, here we can enjoy. So if you go in and type execute, we get execute Python script or R. In this example, we're going to do R, and you have 3 inputs. And what's nice is when I drag this, it tells me I can only connect it to either input 1 or input 2. Basically, if we can just have 2 data sets and potentially merge them or do some logic with 2, but I only have the 1. So now it's time to actually put in the R script. So I go here to this little option, pop out the screen editor. Now, there's no IntelliSense here, so usually you want to use some sort of editor to validate what it is that you're creating. But you're going to go in here and you're going to bring in the R. Now I have this saved. I'm just going to bring this in for ease of use here. So let me do that, and I'll just talk about what it's doing. Some of this is defaults, so I'm mapping the first input. So map input port 1 is going to be mapped into this value of D. So D holds all 398 rows, 7 columns. That's in D. From there, we're going to go ahead and create a new column called MANF. We're going to call it manufacturer. And we are basically going to use some logic within R to break apart that column, where we're going to do a substring, where we're going to get the car name, and we're going to use this regular expression to drive that. So we're basically taking the first item after the space, the first space we encounter, we're dumping the rest. We don't need that. So that's what's happening in 4 and 5. After that, because I'm familiar with the data, this obviously would have been something I would have done in stages because I would have found out. There's some just basic data cleansing. First, there are some, you know, the Datsun became Nissan, so we're just going to consolidate everything. It's the same manufacturer, just 2 different names. So let's bring them all together. Let's make them all Nissan. There is just some of them were Chevy instead of Chevrolet, and there was also some misspellings for Chevrolet, some misspellings for Toyota, Mazda, data quality issues that you could find anywhere, right? So I'm just cleaning it up, organizing it so that we have the values that we want. And lastly, all I'm doing here at the end is making this a categorical feature. Remember I talked about how cylinders was more of a categorical feature? We're going to deal with that momentarily, but I'm making this categorical because I'm assuming it's going to be significantly less values, and I want to see the breakdown of that. So we can go in here. We're mapping it to the output, so I'm going to hit the plus sign, and now I'm left to connect this to something. So I just have to choose what I'm going to connect it to. So for us, and I can run this, like I said, we're adding a new column. Remember what I mentioned? If I don't run this, nothing will see that new MANF column. It's just not going to exist. So let's go ahead and run this so that we have MANF. We can visualize it and see how it's looking. And it's going to be categorical too, which is nice, so we can visualize it. So I'm going to right-click the result set, hit visualize, and we can see I've got my manufacturer. So if we look at acceleration now by manufacturer, we get these box plots, which is nice. So Ford, we can see here's the min, here's the max. We have our box, which is going to be the quantile here. So the 25% to 75%. So there's a large breach out here, and then our mean. So some interesting information. Plymouth has got some outliers here where everything kind of falls in here, and they have a couple that are super fast acceleration, right? So there's some oddities here we might want to think about. These are things we take note of. Remember, we're going to run an experiment and think, well, maybe this was an issue. Let's look at maybe how that would affect it. We definitely need to eventually dump car name though, right? That needs to go. So what we'll do next is let's look to see, is there anything here? This is also very important. Horsepower is one of them. Missing values. Now it should be noted there's something really nice that you can do if you wanted to. It's called summarize data. Sometimes I do this at the very beginning. I just like the way it natively looks, but you can connect the summarized data. This is just something part of the EDA process. I'm going to delete this in a moment, but just so you can see how this works. All those stats that we saw on the right-hand side, the min, the max, we're basically pivoting that, and we're seeing it collectively here. So just a different way to look at that instead of that preview screen. Here is the count, unique count, missing value count. So this is what I'm interested in right here, the missing count, and horsepower has missing values. This is critical. You need to handle missing values, and you have to have choices. So this is what we're going to talk about, and this is what we're going to deal with. We need to clean this up. So let's remove the summarized data, and we're going to bring in a clean missing data. So this one's really nicely labeled, clean missing data. Just like that, drag that in, connect the dots. And the interesting thing is here, this is important to note, when you're doing cleaning, you basically decide a rule, choose what columns this applies to, and that's it. You can only have one cleaning rule per module. So if you want to clean like this column one way and a different column another way, you have to bring in two separates. So that's important to note. For us, basically, we're just saying if there's any missing values, in this case, we know where the missing values are just in horsepower. What do we want to do? Now, there's custom substitute value. So right now, it would just replace everything with zeros. A pretty popular one is replace using mice. I forget right now multivariates, what mice stands for, but the idea between mice is the more values that exist, and you're looking at it within a column. So we have 398 columns and only 6 missing values. So this is a possibility we could definitely use mice. Based off of all that, it uses multiple statistical approaches to figure out values to assign for those missing values, for those gone. So that's a very plausible one we could use. Right now, it just replaces them with zeros, but we've already talked about that this is a high impact, very important predictor column for us. So for me, even when you use mice, even when you do some other sort of average, you can say replace with the mean, the median, the mode. Even if we choose one of those, there's a potential we're introducing some degree of noise, some error. It is just an assumption, right? We're trying to get close. In these scenarios where you only have a little bit of missing rows, sometimes it's good to just get rid of the entire row. This is a highly predictive column. We don't want to have anything done wrong there. So I'm going to go ahead and get rid of it. So now we're going to go down to 392 rows. And with that being said, we'll go here. And for the sake of this demo, we'll say that we're satisfied with this. We're going to say we're happy with where it's at. You know, as far as this, we've got 392. I have no more missing values, MPGs there. I like it. I like it. Cylinders was the questionable one. We do have to get rid of car names though. So let's go ahead and do another select columns. Got to get rid of that. There's a potential here that I'd also might add in cylinders after the fact. So we'll start with all columns, and we're going to exclude car name, just like that. And I'll run the selected, and we're happy. We've got what we want. So now we go to the modeling side, right? This is the whole area where I'm going to show you the very standard traditional method of doing this. And that's going to be where we choose a training data set and we use a testing data set. And the way we're going to do that is using what's known as a split data. Basically, we need to feed into our algorithm, right? We remember the whole thing with algorithms. We need to pass it data that we know has the answer so we can have it learn patterns and have something we can immediately validate on. And then we're going to test it on data it hasn't seen to get the end predictive power score. So what we need to configure here is this fraction of rows. Think about this as a percentage. If I left it at 5, it's going to go right down the middle. So whatever half of 392 is, that's going to go to train to help us figure out patterns, and then half is going to go to be tested on. Usually you want to give this a little bit more, 65. I'm going to go 70% here. It does a really good job of basically making sure of the 70 that go over there, like keep maintaining a nice even distribution. But just in case you can turn stratified split where it samples it, it just takes more processing power, but it ensures the distribution. But I've had great success where it just does this innately. So now we need to go ahead, split this data, and we need to pass it to something. So we're going to pass it and we're going to train our model. We're going to start to try to figure out and learn a pattern here. So I'm going to go here and type in train model, drag that in. This here, as you can see, it's looking for a data set and we want the training data set. So this is the 70% side, that's what I'm passing. And it's looking for some sort of untrained model. This is where we are going to go and pick an algorithm. So let me just navigate down to that. There's quite a few things here. This is going to be right in my, there's a lot that opened up here. 1 second. We don't want this. We don't want you. In machine learning, this is what we want. We want the initialized model. We want here. All right, cool. So in initialized model, we have anomaly detection, classification, clustering, and regression. So these are the different ones we saw. Now what we're going to start is with the standard one, linear regression. I'm going to bring this in and connect the dots. It shows me it's green. And once again, this is, I'd say, the grandfather kind of original, the most commonly started with option for an algorithm when you see there are linear patterns of the data. So that's what we're going to go with, but there's some parameters you could tweak. So I've got this. The trained model just now needs to know, hey, what's your label column? What are you trying to predict? So I'm going to go over here and just point to acceleration, hit the check mark, and what we need to do next is score the model. So I'm going to bring in a score model. And lastly, and this is also asking me what the, we need the testing data set. Shoot, so score that, all right. Let me give myself a little room down here. And lastly, we're going to go ahead and put in and evaluate. A lot of times you might go through the process and just run it and see what the score looks like and then evaluate it basically against the testing data. How did it do? But I'm going to put it all together here because we're running a little bit close on time. So we're going to feed some data which has the answer. We're going to give it acceleration. It's going to figure out patterns, try to get as close to some patterns as we can find. Then we're going to run it against unseen data where it doesn't see acceleration, but we have it. Compare the results. Basically, we're going to see it's the correlation. We're going to compare the results of the scored, the label column, and see how well it did. And we're going to see it's called mean absolute error or coefficient of determination. Those two is what I mainly leverage to kind of indicate what is my predictive power, especially when you compare one model versus another. So I'm going to go here to evaluate model. I'm going to right click. We're going to hit visualize. And we've got our mean absolute error. Remember that line I talked about in between? This is the average amount that either up to the left or to the right of that line it'll go, so the lower the better. This is not bad. And the coefficient of determination, you can think about this as being the predictive power here, 66% of the time it'll be able to predict this. This is okay, and just for doing something really simple, it's not bad at all. But just the last thing we're going to do is you can very easily compare this up against something else. So I can just go right in. I can grab something else and be like, well, maybe it's not linear data. Maybe it's nonlinear data. So I'm going to bring in a neural network. I'm going to bring in a trained model and a score, so I can just copy these over, which is nice. It keeps the information. So remember, my train needs, it's 70%. The untrained model, that's going to get done, and then score model is going to get put, because you can compare two models to each other. Oh, I need my training. So we can run this, and this will be the last thing. We can do this, so hang with me here, because there's some stuff I want to talk about. And we can compare these to each other, get a better understanding. Is the data overall more linear? Are there more identifiable, relationships that are easily identifiable here, which the linear regression would perform better in? Or are there more nonlinear pieces of the data, kind of like when we were looking at weight, where we need to take more of a predictive approach, more of a black box learning operation, and see this. Now, when you use these neural networks or these more predictive, these more deep learning type algorithms, they do take a little longer. So in the overall scheme of cost and price, the running time of an experiment does matter. So when you can, and this is important, let's see which one does better. So right off the bat, this doesn't necessarily mean that right now, as the experiment is, there's more linear data than nonlinear. That's what we can gather, but there's some things we could have cleaned up. What's up with cylinders? But it's safe to say that the linear is better. Now, if the coefficient of determination was around 60, it was really close. Let's say it was 0.67 for the neural network, that deep learning, that predictive algorithm. You would want to, I'd probably go actually with the linear one, only because it's a small marginal difference and it's more explainable, right? The idea and something you want to keep in mind when developing and creating these experiments is the law of parsimony, which simply states simplest is best. That's what you can keep in mind for maintenance purposes, for making different transformations. Simplest is best. Now, it should be noted, you can only compare two of these together, but we could have brought in two more algorithms and just done a whole nother evaluate model, so we'd have to go between them both. But you can keep checking which one's better. Maybe a decision tree would handle this better. This is that experimentation process. This is where you can have fun, take a look, and when you're set and you're done, all you need to do is say set up web service, click predictive web service. Oh, I need to actually pick my model. This is the key thing. You pick the one you like. So let's say I like that one. Let's go ahead and close this. I'm going to save this as acceleration. That's the idea. Once you figure out this is the one I want, this is the one I want to put out there, we're going to go ahead and save that. And I need to run this, because we need to have the finished results here. And all you do is hit publish to web, and you're going to see it takes this fun little action. It creates the web service for you. It's really unique, really interesting, and I just wanted to show this last piece here. So thanks for staying past a couple minutes. Set a web service, publish, and you're going to see some fun little moving. It ended up creating a training model and a prediction model, which it's adding in an input and an output to a web service. So pretty neat, pretty fun. Let's bring it all together, and we are done. And if I wanted to deploy this, I would just need to run it. Once we run this, it validates that it's in working order, because now we have the web input and web output. I can just hit deploy, which is great, and then that gives you all the API information you could want and you could need. So as soon as these all hit green and hit check marks, anytime now, gotta wait, gotta run these experiments. And I can just hit deploy. And this brings you to a link. This literally has everything you need. If there's a team that is good for API or app creation, this is everything. Here's the API key. If you go to request response, you have everything you can imagine here. Here's the URI, all the requests. If you scroll down, there's a whole section down here about, here's the sample code for C#, Python, R. You can just export this and you're good to go as far as accessing this from an intranet, from an app. This is all the resources you need. As you notice, it's an option that's here now in this web service area, so you can always access and get to this. So thank you guys for sticking with me. I know that was really quick. Data science is so deep and so involved, and machine learning is just a great interface to allow you to create these experiments. It's really fast, really easy, so hopefully you enjoyed and you got to see it. I know there are some questions, so I'll make sure to address that. I wanted to check, Crystal, were we able to get that item that we want to showcase here?
Yes, it's sitting in your email. You want me to?
Let me bring this up real quick here for you guys. All right, so there it is, but I need to put it on this screen. So just in case for any of those who have attended here, there's a little promo code. You can get $100 off any on-demand training purchase. If this is of interest to you, if you're interested in our anything else, we actually have a ton of other things, and we have just released Azure Data Factory. We just redid the Azure Machine Learning. We're going to have Azure SQL DB coming. We have Power Apps, Power BI, you name it. There's a ton of stuff if you're not familiar with this, but here's a little promotion for you guys sticking with me to the end. I appreciate it, and I hope you guys enjoyed, and this will be up and recorded and available to you. So thank you, everyone. I hope you have a great rest of the day.
All right, thanks, Manuel, and thanks everyone for attending. Like Manuel said, this will all be recorded. You guys should all receive an email link tomorrow, but if not, it will all be on our website. Thanks so much, guys.